method here. So again, it will yield the same thing as substitution. It will yield the same information as graphing. Okay, so all that information is still the same coordinate. Okay. On your quiz at the end of the week, you will be asked for certain methods. Okay, if you blank out on one of them, use a different one. The answer should be the same. Okay. All right, but we'll talk more of that with the review. So elimination involves eliminating a variable by combining the individual equations within the system. One way to combine the equations is using addition. Now, as we go through this, it's going to say use addition and then use subtraction. I'm going to show you a way that you can always use addition, just to keep it simple, but it's technically the same thing. Now, before we get into this, I want to remind you of elementary school skill. We'll see how many of us remember it. If I were to give you 375 plus 124, how would you add that? So you add them in columns, right?
Yeah.
So you have your ones column, that would give you what?
9.
We're using that type of a concept. Now, obviously, it's X's and Y's, okay? But the reason being here, we have a hundreds column, we have a tens column, we have a ones column. As you do this, I'm not really gonna, this is what I'm summarizing in this chart, so just read it as you would like to. But you actually want these to be in standard form. So this is opposite of substitution. You don't want a variable isolated, you want them all lined up the way they should. So your X's are lined up, your Y's are lined up, equal signs should be lined up, and then the constants. So they should be in standard form. Yes?
Will there ever be a time when it's not in standard form and we have to like convert it?
If you're asked specifically to use elimination, they all should be set up like this. Okay. If it says pick any method, that you may, if you want to use elimination, you may have to move it around to get it here. But if Y is isolated already or X is isolated, I would just use substitution at that point. Okay. Now what you're looking for, so tomorrow you're going to need to manipulate one or both of the equations. Today they'll be basically set up to eliminate either X or Y upon adding or subtracting. So what we're going to do and what we're looking for is when they're all lined up, we're looking for like coefficients. So for example, both of these are 5Y's. One is positive, one is negative. That is what you are looking for to do for elimination. If it's not there, we're going to be manipulating at least one of the equations to make that happen. Since this is already set up, a positive 5Y and a negative 5Y, if we add together now, those will be eliminated. Okay. So 3x plus 5x would be what? 8x. 5 plus negative 5. 0, meaning eliminated. Hence elimination.
Oh.
Okay. Equals 16. Okay.
So x equals 2.
Yes. So we'll divide both sides by 8. So this is to deal with, again, substitution. We deal with one letter at a time by plugging one equation in for something else. That way we only solve for one and then the other. It's the same concept. It's just different method for finding the first variable. So the 8's cancel out. We get an x value of 2. Okay. Now we still need the y. The y is the same thing we did in substitution. So that's why we learned substitution first, because the second half is still substitution. So we have to plug this 2 back into one of the two originals. So that's why we learned substitution first. Okay. So we still have 2. So you're still looking for a coordinate. Would you guys rather plug it into the first equation or the second one?
The first
The
one.
first. It should not matter. Okay. Now, later, especially tomorrow, when we start manipulating, because they're not always set up to eliminate immediately, so we're going to be doing some stuff with those. But I would always encourage you to go back to one of the originals before you eliminated anything. Okay, so first one is fine with me, so I'm going to plug 2 in for x in my first equation. If you want to do the second equation, that is fine. This is to solve for y. Okay. Everybody with me so far?
Oh.
This is not news. Okay, we've been doing this for a couple days already. This is substitution. So 6 plus 5y equals 11. Isolate y, so we would subtract 6 now. What's 11 minus 6? 5. 5 divided by 5?
Or 1.
1. So y equals 1. That is the same coordinate we would get if we graphed. That is the same coordinate we would get with substitution, just with a different method. So, we added right away because these were like coefficients of opposite signs. That is what you want to get to eliminate. Okay, so if it's not there, we're going to be doing stuff to at least one of the equations to make that happen. But for today, they're pretty much going to be set up that way. Okay, so the eliminating part is just to find the first letter, the second letter, whatever it may be, is substitution still, which is why we learned that first. Questions? All right, if you're like, this is easy, no problem, go ahead and work faster on the next one. Is it set up to be eliminated? As is.
Yes.
Okay. Do you have like coefficients of opposite signs on one of the two letters?
Yes.
On the x's this time. Okay. So that means we can go straight into adding, because 5x plus negative 5x is 0. So those are eliminated. Okay. What is 13y? Either plus negative 3 or you can do the same amount as minus 3.
10.
So this will be a 10y. 20 plus 30 would be 50. Okay. So if you have opposite coefficients, meaning one's positive, one's negative, it doesn't matter which one's on the top or bottom, as long as they're opposite signs, those will become 0, hence eliminating. We would then divide both sides by 10, and 50 divided by 10 would be a 5. Now that's the y coordinate, so make sure to put it in the second spot, not the first one. And then we substitute it back into one of the two original equations. Which one would we prefer?
The top one.
Top. If you want to do the second one, go ahead. So 5x plus 13 times our y value of 5 equals 20. Are any of you doing the second one? Just out of curiosity. Okay. You should get the same answer. It does not matter. 13 times 5 is 65. Then we would subtract 65. 20 minus 65.
Negative 45.
Negative 45. Divided by 5 would be a negative 9. Those of you that did this second equation, you still get negative 9.
Yes.
So it should not matter. So whatever one you feel like you like better, use it. Okay. Generally, most people will pick the ones with the smaller numbers, but sometimes they all have kind of the same amount of larger numbers, so it does not matter. If you want to be extra sure, do both. Okay. So these were both with adding. Now, when we do, you'll notice it says addition and subtraction. When I show you subtraction, it's the same thing, but there's a reason why you would subtract versus add, but if you want to keep it adding, I will show you that also. Okay, make it a little bit more straightforward. All right. Questions so far in elimination? Okay. Now we're going to write this equation. 7 times the number x minus 4 times another number y is 13. Negative 7 times the number x plus 7 times another number y is 14. Find the two numbers. Okay. Now, if you want to do x is the first number, y is the second number, if you want to write that out, that's fine. But since it's already kind of labeled for you, I'm okay if you don't. These we started with at the beginning of the year, just writing equations. So the first sentence, 7 times the number x minus 4 times another number y is 13. What does that look like in an equation?
7x minus 4y equals 13.
The word is means equals. Okay, so wherever you see that word. Alright. Now keep in mind, once you set up the first one, regardless of the order in which the second one's written, make sure that it's the x term first, then the y equals a number. Anyone tell me what the second equation is?
7x minus
Negative
That's
7.
negative 7x.
Okay.
My bad.
What was the second one?
Negative 7x plus 7y equals 14.
So that came from negative 7 times the number x plus 7 times another number y is 14. Okay. The word is an equal sign. Okay. Is it set up to eliminate right away?
Yeah.
Yes. What letter is going to be eliminated?
X.
X.
Yes. Okay. So as we expand on these, go through subtraction, and then tomorrow is going to involve some multiplying because it won't be set up this way. Your goal is to make this happen so that you can eliminate. Okay? So just as we go. Today they're going to be very straightforward like that. So negative 4 plus 7. 3y. 13 plus 14.
7. Or 27.
27. Divide by 3. Y equals 9. Okay, so the second number y is 9. Okay, so if it asks what's the two numbers, technically it doesn't matter the order, but keep it in the x, y. So if we have our two coordinates, so 9 is the second number. Go ahead and plug that back in to one of the two equations. Does not matter which. So we're plugging this back in. Do you guys want to use the first one or the second one? First one? If you want to use the second one, by all means. So that'll be 7x minus 4 times our y value of 9.
Oh, I did not press X.
Make sure to put in the right letter. Equals 13. Negative 4 times 9 is negative 36. Add 36 to both sides.
I know.
7x equals 49.
7.
Divided by 7. The x value is 7. So the two numbers, if it says find the numbers, technically the order you write them in doesn't matter, but if you want to keep your x, y order, you don't need the parentheses, but 7 and 9 would be the two numbers. Okay. Again, just a good rule of thumb, plug 7 in for both the x's, 9 in for both y's, make sure this side comes out to 13 and this side comes out to 14. Okay, just as good practice. Everyone clear on how to write that equation? So that was all with adding. So again, you want your x's lined up, your y's lined up, equal signs lined up, and your numbers lined up. You're looking for opposite coefficients. Now the reason that you would even use subtraction is if they are not opposites. So if you have the same number, but they're either both positive or both negative. Because if you add them, then they won't go away. So subtraction, I'm going to show you another way to think about it also. So when the coefficients are the same in two equations, you can eliminate the variable by subtracting one equation from another. Okay. Now if you think about it as subtraction, a lot of people make a very simple mistake with it, which is why I will show it to you both ways and then you can decide which way you like. Okay. So instead of adding them both, you will subtract basically the second one from the first one. All right, so the reason being, okay, if we were to add these, I'm going to erase it in a second. So if we were to add these, I would get 8x plus 12y equals 36. My job's to get rid of one of the variables. I still have both. This is not going to help in any way. So the ones that are, erase. The ones that are matching coefficients are which letter? They both have the 6y. One has to be negative. Okay. Now if we subtract it, it would be negative, but you have to subtract the entire line. Okay. So you would have to subtract everything. So again, just throw a minus sign out here. It is all of it. Okay. So let me remind you again of if we did subtraction with just normal numbers. So if I did 3 75 minus 134, okay? It's the 5 minus the 4, correct?
Yeah.
To get a 1. It's the 7 minus the 3 to get a 4. 3 minus the 1 to get a 2. Okay? But it's minus everything. So that's why I put parentheses around it, because a lot of people, they'll just subtract the one that they want and then they add everything else by accident. Okay? So in doing so here, if you did it this way with using subtraction, 3x minus 5x would be what? Negative 2x. Okay. 6y minus 6y. 0. 30 minus 6.
24.
Okay. Now some of you are like, that's fine. Okay, no issue. Those of you that are like, I don't know if I'll remember to this minus that the whole way. What you could do instead, and it will get you still negative 2x equals 24. That's not going to change. You would multiply the second equation by a negative 1 and distribute it in there. So instead of, let me just erase this. So if you're fine with this, that's fine. Okay. You would multiply the first equation by a negative 1. Okay. I'm going to distribute it in there. That way it's the more visual way to go about doing that. Alright, so I'm going to recopy the first one because I didn't do it anyway. Okay. I didn't change the first one. Now I have a negative 5x, a negative 6y, and a negative 6. And you would add those. It's the same thing as subtracting, but for those of you that are worried you're going to make a mistake with the subtracting, maybe multiply one of the lines. Actually, it doesn't matter which one. Multiply one of them by a negative 1, which means change all the signs, which would be subtracting everything. But some of you will make mistakes going top line minus that term. Okay. So in doing so, this is what we're going to have to do tomorrow. You'll have no way around it. We can't just go into adding and subtracting because they won't match. So we're going to have to multiply one of the lines by something, or both of them by something. So if you want to get in the hang of that, you could do that this way. So this would still eliminate those, because now 6 plus negative 6. We would still get a negative 2x equals 24. So it doesn't matter if you think about it as subtracting or multiply a line by negative 1, then add. It's the same thing. Yes?
So basically you use subtraction when there's two like not opposites.
Right, so when they match, but their signs are the same.
Okay.
So you change it to subtraction. If you want to just keep it as addition all the time, change one of them to a negative 6. So if I want to change it to a negative, I'd have to multiply it by negative 1. But in doing so, multiply everything by negative 1. Okay. All right. If you want to just go straight up into subtracting, that's fine, but there's more errors that way, I have found. Okay. So any other questions about either way? There's no difference. It's just, do you like seeing the minus signs there? Or do you like thinking of it about, well, 3x minus 5x, 6y minus 6y, 30 minus 6. If you're okay with that, then do that. Is everybody clear that I'm giving you permission to just pick away? Okay. Now, once we get to this point, how do we solve for x? And 24 divided by negative 2? Negative 12. Now I'm just going to go, if you guys have a lot of room, I don't remember how much room I gave you. You can go straight down just below it and do the y's, but if you have room next to it, by all means, I'll just keep it next to. Now, I would not use the manipulated one, go back to one of the two originals no matter what. So do you want to plug in negative 12 in the first equation or the second one? First. If you want to do the other one, that's fine. So 3 times our x value of negative 12 plus 6y equals 30. Or you put it in for the x next to the 5. Okay. Either or. 3 times negative 12 would be negative 36. Add 36 to 30. 6y equals 66. 66 divided by 6? 11. So what's the coordinate of intersection?
Negative 12, 11.
Negative 12, 11. Again, same answer we would have gotten had we substituted. Same example, or answer we would have gotten had we graphed. Question. Okay, I want to give you time to try this one. So you either need to subtract because the three y's match, so adding them is not going to help, or multiply one of the lines by -1 first, then add it. It's the same thing. Okay, so solve it all the way till you have an xy coordinate on D. So I'll give you a little bit of time for that. And today they will either be set up so that you can add right away or you can subtract right away. Tomorrow they will not. We'll have to manipulate one or both of them to make that. Correct. So tomorrow we'll have to either multiply one of the lines by one number to match the other one, or we'll have to multiply both to get the least common.
My bad.
Doesn't change
So this is
anything about
negative.
the process of eliminating.
Negative 30.
It's nothing,
Oh,
it's just the first step.
Dude, I'm so dumb.
Over 2.
And you don't have a coordinate answer yet?
What? What do you mean?
Over
Lizzie, what do you have?
Negative 3, 14.
-314.
Why is 30?
Yes, that's what you should have gotten.
2,
Okay.
2,
So, just out of curiosity, who just did
30.
subtracting?
Oh, I did see.
Okay. Who multiplied a line by -1 first and then added? Okay. So I'll do this one just straight up subtraction. So if you don't like that, okay, just keep in mind it's the top one minus whatever its like term is. So that generally is the issue when there's a minus sign, is just forgetting. Okay. So -2x minus 7x would be what?
Is that gonna be 40?
Oh,
2x
negative
equals 40?
9x.
Good, so -2 minus 7 is a -9x. So the issue there is just forgetting it's minus and writing a 5x. Okay, be careful with that. 3y minus 3y, 0. Okay. 48 minus 21.
27.
So the issue that I've just found with some people, a lot of people are fine with it, okay? It's usually 60-40, something like that. Is just forgetting to subtract to all three. Okay. One thing you could do is just write a minus sign next to all three of them, instead of writing it like this. Okay. Then we would divide by -9, which is where the -3 in the coordinate is coming from. Just out of curiosity, how many of you plugged it back into the first one? How many of you plugged it back into the second one? Okay, so it's about 50-50. A lot of people didn't raise their hands out. Okay. So plugging -3, if it was me, I'd probably pick the first one, just because slightly smaller numbers on the left side of the equal sign, but it does not matter. Either way, you should get 14. So this one, -2 times -3 would be a +6. Subtract 6 to the other side, which give you 3y equals 42. If you're not good with these, use a calculator. And 42 divided by 3 is 14. For this one, you would have gotten the -21 added to, well, then change the sign, add it over, you would still get 3y equals 42. So it should not matter. Okay. So does everybody understand why you would use subtraction on these two versus addition like we did in the front? Okay. So either you manipulate one of them by multiplying the whole line by -1, then adding, so it's just adding every time, or subtract, which is the exact same thing. It's just different people's, different minds work differently. Okay. All right. We good so far? All right. Word problem, and then we're done for the day. Washing 2 cars and 3 trucks takes 130 minutes. Washing 2 cars and 5 trucks takes 190 minutes. How long does it take to wash each type of vehicle? Okay. Now define your variables.
Cars is 2 C.
You know what I mean?
What about the cars and trucks?
How long?
How long to wash
Also the
a car? Because it tells you how many cars and how many trucks. It's just how long per each one. Now, do you guys want to use X and Y or C and T?
X and Y.
Okay. You can use whatever letters you want to. If you're going to use a T, just make it not look like a plus sign. So either a capital T or curve the bottom of it. Doesn't matter which is which. Meaning is one variable independent of the other. No. Cars and trucks are both vehicles. So, how long to wash a car and how long to wash a truck. Okay. So it's not how many cars and trucks, it's how long to wash each type. Alright. Who can tell me the first equations? Great.
2x plus 3y.
2 cars and 3 trucks equals 130 minutes. Okay. What about the second equation?
2x plus 5y equals 190.
Does it matter which equation's on top, which one's on the bottom? No. Okay, so if you want the second one on top for whatever reason, you can. It does not matter the order. Are we going to add these or subtract them? Subtract. Okay, because the 2 x's are aligned nicely to eliminate, but if we add, we're going to still have an x and a y. We want to eliminate one of them. So you can subtract instead of add, but make sure to subtract the entire line. So what I mentioned before is if you essentially distribute this minus sign, instead of writing the parentheses, what you could do in place of that notation, if you know you're subtracting, you could just put a minus sign physically there if you wanted to. I'm going to write the parentheses, however. So, 2x minus 2x would eliminate 3y minus 5y. Negative 2y, 130 minus 190. Negative 60. So if you struggle with the minus and negatives, if they show up, if you're subtracting a negative, use a calculator for that, just to make sure. Okay. Negative 2 gets divided from both sides to get what? 30. Now what does y equals 30 mean?
30 minutes per truck.
Okay. So trucks take 30 minutes to wash. Okay. Now we still don't know cars. Okay. Make sure if it's a word problem. Now the last word problem that we did on the front, it was just what are the 2 numbers? That's why we just listed them. But if it's something cars, trucks, cats, dogs, make sure to identify which one's what. Do we want to plug it back in for the y in the first equation or second? Okay. So 2x plus 3 times 30 equals 130. Okay. Or you plug it in next to the 5 in the second one. 3 times 30, 90. You will then subtract 90 from 130, which is what? 40. Divided by 2? 20. So x equals 20 means what?
20 minutes to wash the tank.
So cars would take 20 minutes to wash, trucks would take 30 minutes to wash. I'm assuming they mean cars like sedans. Okay, that type of car. All right. So main focus today, these are all, they're ready to be eliminated right away, either by adding or subtracting. Okay. Tomorrow they will not be. You might have like a 2x and a 4x and a 6y and a 3y. And we're going to have to figure out how to make one of those match. Okay.
So
Which is not
for-
difficult.
For our homework, it doesn't matter if we add or subtract.
Correct.
Okay.
Okay. So your assignment, that seems like more than it is, 18 through 29, that is 12 problems. Okay. All right, so get started on that.